Whoever discovers a cure for hearing loss is going to become insanely rich. Hey guys, Cliff Olson, Doctor of Audiology and founder of Applied Hearing Solutions in Phoenix, Arizona. And in this video, I'm taking a look at where we currently stand in our search for a hearing loss cure and why a cure hasn't been found yet. So listen, I know that there's a lot of people out there who want us to find a cure for hearing loss, and anything less than that is completely unacceptable. They don't want me talking about hearing aids, cochlear implants, auditory brainstem implants, or any other forms of treatment unless they result in a complete restoration of normal hearing. I get it. I also know that there's a lot of people out there that believe the reason why there's not a cure yet is that hearing aid manufacturers are preventing a cure from being discovered. And yes, if a cure was discovered, the hearing aid industry would cease to exist overnight. However, hearing aid technology continues to be the best and most effective form of treatment out there. And yes, there are many reasons why a cure for hearing loss has not been discovered yet, but none of them have anything to do with the hearing aid manufacturers. That's why I'm going to be talking about all the promising potential cures for hearing loss and why none of them have been successful yet. But before I do me a huge favor, click the like button, really helps out the channel. And if you are not yet subscribed to the channel with notifications turned on, go ahead and do that as well. It's greatly appreciated. And let me know down in the comments section if you have a conspiracy theory as to why a hearing loss cure has not been discovered yet. Okay, so when I'm talking about a cure for hearing loss, what I'm really talking about is hair cell regeneration. The fact is, most hearing losses on this planet are due to the deterioration of both outer and or inner hair cells. There are approximately 15,000 outer hair cells inside of your cochlea, which is your hearing organ. Outer hair cells are essentially your natural ear amplifiers. They take the vibrations of natural sounds and increase those vibrations along the basilar membrane. If there's enough vibration along the basilar membrane, your approximately 3,500 inner hair cells will receive this vibration and convert it into a neural impulse that travels up your auditory nerve to your brain so you can hear. Now, it's important to understand that when these hair cells are either missing or become damaged due to things like genetics, noise exposure, age, chemical exposure, or head trauma, these hair cells do not come back. So if you're looking to cure hearing loss, you have to be able to restore the structure and function of these outer and inner hair cells. Now, so far, the three most common forms of therapy that have been researched at this point are genetic therapy, molecular therapy, and stem cell therapy, but all three of them have their roadblocks. Let's start by talking about genetic therapy, and in my opinion, this one has the most promise out of all of them for a few reasons. First, this form of therapy would be used to convert support cells that are already inside of your cochlea into functioning hair cells. This would prevent the need from having to transplant hair cells into the cochlea, which may do more harm than good. The way that researchers have been approaching this is by uploading a gene onto a virus and then putting that virus into a human. That virus would then take that genetic information, upload it to the cells of the human being, and essentially alter their genetic code. If you ask me, that would make for a crazy sci-fi movie. The ability to do that in and of itself is mind-blowing. And the second reason why I believe that genetic therapy is one of the more promising therapies out there is that researchers have already been successful using this strategy to reverse some forms of genetic hearing loss in children. For instance, there are children who are deaf due to a faulty OTOF gene. And by using a virus to deliver a functional OTOF gene, they've been able to reverse deafness in these children. However, when it comes to adults who have a hearing loss that has not been caused by a genetic abnormality, researchers have identified that you can't just fix one of these genes. In fact, when I was back in grad school, I was already looking at the research into hair cell regeneration using genetic therapies, and when they isolated a single gene inside of these adults who had hearing loss due to a variety of different reasons not related to their genes, they were not really successful. But don't worry, because researchers are already looking at multiple different types of genes that they can upload into these viruses to change the genetic code of human beings to hopefully restore hair cell function. Will they be successful? Who knows? But this leads us into our second form of therapy, which is molecular therapy. The concept behind molecular therapy is that there might be a combination of different drugs that you could either ingest or inject into your ear that would stimulate the regrowth of hair cells. The most promising molecular drugs that we've had over the past decade were from a company called Rinri Therapeutics, and their drug candidates were known as FX322 and FX345. These particular drugs were injected transtympanically through the eardrum onto onto the round window of the cochlea, and then these drugs would permeate this membrane of the round window and get into the cochlea to stimulate progenitor cells to recreate hair cells. These particular drugs did show some promise in early phase 1A clinical trials. However, during the phase 2 clinical trials, they did not identify any restoration of hearing, which caused them to terminate and cancel any future research into these drug candidates. Now, don't let that discourage you, because a couple years ago, there was research that came out that combined both molecular therapy and genetic therapy to leverage the synergistic effects of both of them. In this particular study, researchers were able to regrow hair cell-like structures in adult mice by using a coactivation of MYC and Notch1 to reprogram supporting cells and promote hair cell regeneration. However, as you can imagine, there is a big difference between regrowing hair cell-like structures inside of mice and regrowing functioning hair cells inside of adult humans. As of right now, this research has not translated into actual human clinical trials, so you can tell we are still early in this process. But that leaves us with the third form of hair cell regeneration therapy, which is stem cell therapy. Okay, so the form of stem cell therapy that everybody really wants is for us to be able to reprogram adult stem cells and turn them into functioning hair cells that we can then implant into the cochlea to restore hearing. To accomplish this, researchers would have to be able to develop induced pluripotent stem cells in a lab that are capable of creating cochlear organoids and hair cell precursors, and then somehow transplant these lab-grown pluripotent stem cells into a human cochlea in the right location and have them innervate with the auditory nerve. Unfortunately, it's very difficult to transplant these hair cells inside of a human cochlea without causing more damage and actually ensuring the survival of these hair cells. As it turns out, the chemical composition of the fluid inside of the cochlea is extremely harsh. But don't get discouraged, because there was some exciting news out of the UK with the first ever stem cell therapy in humans performed by a company called Rinri Therapeutics. They were able to deliver stem cell derived auditory neurons into a cochlea during individuals' cochlear implant surgeries. To be clear, this was not intended to regrow hair cells inside of the cochlea. It was intended to rebuild the neural connection between the ear and the brain. The loss of auditory fibers and neural synapses is a huge problem when it comes to age-related hearing loss, auditory neuropathy, and hidden hearing loss. RinCell1 uses laboratory-grown otic neural progenitor cells to regenerate damaged auditory neurons in the inner ear and re-establish neural connections. It's not technically a hair cell regeneration therapy, and it is not intended to cure hearing loss. However, RinCell1 could be very beneficial if combined with another form of therapy when attempting to cure hearing loss. At the end of the day, we are still a long ways away from finding a cure for hearing loss, but I can promise you that it's not due to lack of effort, and it's definitely not due to a lack of funding. Estimates suggest that there's over $500 million in federal funding that goes towards hearing loss research every single year. On top of that, it is estimated that hundreds of millions of that federal funding is specifically going towards hair cell regeneration research. And that does not even include the private biotech companies that are investing hundreds of millions of dollars to searching for a cure as well. And you can top all of that off with another couple $100,000 in the form of nonprofit funding. So as you can see, searching for a hearing loss cure has very little to do with the amount of funding, and it has a lot to do with the complexity of human biology. Will we have a cure someday? Who knows? Me personally, I believe that we will. I just don't think that it's going to be anytime soon. But you should know that waiting for a cure and foregoing common forms of treatment like hearing aids is not without its risks. Not treating your hearing loss right now with available treatment options is a decision that could come to haunt you in the future if it reduces the potential benefit from a cure once it's discovered. Not to mention the decades that you would spend struggling to hear because you didn't want to entertain the idea of using hearing aids or a cochlear implant because it didn't restore your normal hearing. And think about it, even if hair cell regeneration does work someday, there is no guarantee that it's actually going to restore normal hearing. But I want to hear from you. Are you avoiding treating your hearing loss right now because you're waiting for a cure for hearing loss? Let me know down in the comment section, and I'll see you in the next video.